Hey, 7th grade, we are going to go ahead and get started on Chapter 10, which is the last chapter of our textbook. Yay! So, this is the last bit of notes that I took, and on the next blank page, you can see that I, very sloppily, sorry about that, wrote Chapter 10. And then at the top of the very next page, I'm going to go ahead and put our heading, which is Chapter 10, Section 1. And the first section is going to be talking about something called scatter plots. And I'm going to put today's date off in the corner. Today is the 20th. And if you did not yet print the cutouts, please pause the video and do that now because we are going to be using them momentarily. So, a scatter plot, that is the bit of vocab that we're going to talk about first. A scatter plot. It's actually a graph, like we've seen on coordinate planes. So, graph on the coordinate plane. And it compares two real-life variables. Most of the time when you see a scatter plot, it's almost always going to take place, or we'll say taking place, in quadrant 1. And that's because most of the time when you're dealing with variables in the real world, they're almost always both positive. Unless you're dealing with something like, Trixie, be quiet! Unless you're dealing with something like temperature or depth below sea level. Those are real life examples where it could be negative, but most of the time it's going to be taking place in quadrant 1. I'm going to show you in a second why it's called a scatter plot. We are going to go ahead and get started on the first one. And this is all about how to read a scatter plot. Alright, what the different points mean. Now, you should have your first cutout. Should look something like that. I'm going to put it right in the middle because we're going to be using it for both A and B. So I'm going to pause and glue it in. Please do the same. Okay, so I have mine glued in. And you can see why it's kind of called a scatter plot. It's because the points for this are all scattered all over, the graph. They're not in one straight line like we're used to. Trixie, I'm doing work. She, of course, picks the most annoying toy. I'm doing a video. So you can see that our graph here has to do with the number of tickets sold and how much money was collected at the soccer game. With our x-axis, hi, I love you too. Don't hit my camera, you brat. You can see that our x-axis represents the number of tickets sold, and the y-axis equals the number of money that was collected. They actually should have moved this up because this should not represent 300. This should be up here. This one should be 0, but that's okay. So, you might be asking yourself, why aren't they in a straight line? Well, things in real life rarely ever end up on a perfect straight line. And that's because a lot of other things affect them. Maybe, somebody had a coupon and they were able to get more tickets for a cheaper price. Or maybe somebody else bought them at the last second and had to pay more money. Or maybe it was a really, popular game and they were able to get more per ticket. Who knows? But there are a lot of factors going into, what might affect the cost of a ticket. But what we have here is data that they collected, the number of tickets sold, and the amount of money that they collected over on our y-axis. And this is what we call a positive correlation. That means it doesn't sit in a perfect straight line, but we can kind of see that they sit in a positive sitting direction. And that makes sense because the more tickets you sell, the more money you would collect. That just, that makes sense. So let's get started. I'm going to pick a point on the graph, and we're going to talk about, well, what exactly does it mean? So if I picked the data point 150 and 1100, or 1100, I should say. What does that data point mean? Well, remember, we always read our coordinate planes, our coordinate graph starting with our x-axis, which is the first number, and then the y-axis, which is our second number. So the first number, if we're going along the x-axis, that would be the number of tickets that were sold. So if we're going to 150, that would be right about here. And then 1100 would be, well, somewhere, I guess it would be, oh no, wait, this is 150. Somewhere right around here. Maybe it's this data point, I'm thinking. So this means, and I'm going to kind of write this out almost like a sentence. The stadium, let's say the stadium. When the stadium, because I'm assuming that's where the soccer game took place, when the stadium sold 150 tickets, they made $1,100. Okay? If I were to ask you, what does, I'm going to guesstimate here because I can't quite see it perfectly, what would this data point mean? Well, that would mean when they sold 300 tickets, they made $1,400. If I asked you, how many tickets did they sell when they collected $2,700? So this time you almost have to read it backwards. You have to see, well, where is $2,700? That's going to be along my y-axis. And the only point up at that height is this one over here. So it must be when they collected $2,700, how many tickets were sold. It looks like each of these lines represents 50, even though they don't have the middle one highlighted. So this would be 450 tickets. So when they collected $2,700, they sold 450 tickets. Okay, so that's how you're going to read a scatter plot. If they're asking you about a specific point, you just have to see, well, what does my x-axis represent in this situation, and what does my y-axis represent? Now what we're going to move into is how to create a scatter plot. So you are going to need a decent amount of space for this. You'll probably need an entire page. So if you're not on an entire page, a whole new blank page, I would go head over there now, because this one's going to take up a good bit of room. So I'm going to put a number 2, and I'm going to put making a scatter plot. All right. And we're going to do 2 examples of these. We're going to start with the first one, and this should be your next cutout here. Should look like that. I'm going to put an A, and I'm going to pause the video and glue this in. Please do the same. Alright, so mine is glued in. As you can see, in this situation, it looks like we are comparing the age of a car to what the value of the car is. When you make a scatter plot, there's a couple things you want to do. Since all of the values are positive, I know that I'm just going to end up staying in quadrant 1. So I'm going to start by drawing, and if you have graph paper, you are welcome to work on graph paper. I'm just going to work in my notebook. I'm going to try to keep both of these, move down a little more. I'm going to try to keep both of these in view. Okay, so does that still work? Yep, perfect. All right, I'm going to draw my coordinate plane, but I'm only going to draw the first quadrant because that's where everything is going to be plotted. Now, My independent variable, the one going along my x-axis, that's going to be the number of years, how old my car is. Now, the least value is 1, but I always should start at 0, because that's where your graph should always start. And the greatest value is 8. And it's always good to go up 1 more, so I'm just going to tick it off by 1. So each line I do is going to count as 1, and I'm going to go up to 9. And of course, I never make my lines long enough. 8, 9. Okay. And I'm also, go down a little more. There we go. I'm going to label what my x-axis represents. This is going to be age. I can't spell today. Oh my goodness. Age in years of the car. It says age in years, just in case you guys can't see it too well. Okay. Along the y-axis is going to be the value, and it looks like, yes, it is in dollars. The least amount is 1,000. The greatest amount is 15,000. So, I don't have a ton of room. I'm going to count off by, I'm going to make each line represent 3,000. That's what I'll do. So, this will represent 3,000. This will represent 6,000, 9,000, 12,000, 15,000, and I'm going to go up 1 extra. It's always good to go up 1 extra one, just so that your entire graph can fit on it without it being smushed too near the top. Okay. So we have plotted everything on our x-axis and we labeled it. We put our scale, all right, how big the increments should be along our y-axis, but we also have to label it. And this is going to be value, and I'm just going to put in dollars. So someone who didn't know what the scatter plot was about, they'd be able to see just by looking at it, oh, you know, here's what they're comparing. So now what we're going to do is we're going to plot each of these value points. Let's start with the first one. Okay, I'm right here. So we're at 3 and then 11,000. Now I don't have 11,000 on here, but I'm going to do it as exact as I can. This line represents 12,000, so I'm just going to go right underneath. That's probably at about 11,000. Then we're at 2. I'm at the next one here. 2 and 12,000. I'm going to do the rest of these. I'm actually going to pause. I'm going to have you do the same, and we'll regroup in just a moment. Okay, so I have all of my points plotted. And as you can see, it's not a perfect straight line, but it seems to be that the older your car gets, the more it declines in value. This is what we call a negative correlation. As one increases, the other is decreasing. In the other one, it was the exact opposite. As one increased, the other one increased as well. Both went up. This one gets bigger, but the other one gets smaller. Now, why wouldn't it be the exact, like an exact straight line? Well, think about it. They're not telling us, you know, what condition the car is in. For example, if you look at these last two, this one's 3 years old and it's worth $6,000, but this one's 6 years old and it's still worth $6,000. Maybe this person took really good care of their car and, you know, that person beat it up or something like that. We have no idea. All we know is the data. We can plot it on our graph, and that's pretty much all the information we get. But we can see, even from that information, that as it gets older, the price starts to drop. Let's try another one. This one's going to be a little bit different because it's going to involve decimals, but we're still going to do it the same type of way. So I'm going to put a letter B, and this should be our last cutout. Looks something like that. I'm going to pause and glue in. Please do the same. Okay. So I have mine glued in, and we're going to go ahead and get started. So it looks like we're talking about the number of absences, maybe of a student, because it is talking about final grade. And it looks like as the absences get bigger, the grade starts to drop. So this is another example of a negative correlation. one variable, the absence, is getting bigger and the grade is getting smaller. So let's go ahead and draw our coordinate graph. Again, this is all taking place in quadrant 1. Both of our variables are positive. All right, along my x-axis, that is going to be my number of absences. So the least is 0 and the greatest is 9. So I'm going to count up by ones, but I'm going to go up to 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, would you look at that? I actually made it big enough this time. Amazing. So we're going to put number of is that how you spell absence? I guess that's right. Absences. And this is in days, I'm assuming. Okay. The other is the grade. I'm going to go ahead and assume that that's as percentage. I'll write that in just a moment. Let's take a look at our values here. The greatest that I see is just under a 90, and the least that I see is 66.2. So let me think how I want to do this, because they're all going to kind of be really close together. I think I might count by 20s going up to 100. Yeah, I think that's what I'm going to do. That's not the only scale you could do. There are many other scales that would be possible. But I'm just looking at the space that I have here, and I think counting by 20s going up to 100 is going to be my best bet. If you want to use a different scale, you are more than welcome to. So we'll do 20, 40, 60, 80, 100. Okay, and this is and I'm just going to turn my book to do this, grade as a percent. All right. Here we go. So we are ready to do it. I'm going to pause and I'm going to plot all of my points, and I will be back in just a moment. Alright, so I have all my points plotted, and again guys, you're not going to be able to get it exact. Just put it about, where it's going to be. So it seems like it starts to decline. Maybe this person, even though they were absent a lot, they're smart, they do their work at home, came back up a little bit, but then it starts to fizzle out. So it almost goes down and then kind of plateaus here. So that is what this scatter plot would look like. When you're doing your scatter plots, don't worry about being super accurate. Just put the point where about it would go, and you should be fine. So that is how you make scatter plots. I'm going to have you guys pause, and you're going to head on over to IXL and practice these skills there.